If the same user appears in both train and validation, your model can look good for the wrong reason. We'll split the data the safe way. You have seen models that score high in validation and then fail in production. That often happens because the same user shows up in both training and testing. By the end, you will know how to set up group-aware splits so validation checks real generalization, not memorization. I'm Professor Pi, teaching AI foundations with simple Python. Think of a recommendation task where 1,000 users each produce a few events. Success means your model works on users it has never seen. Group-aware splitting solves the pain of leaked user information, so your reported metrics match real-world behavior. At a high level, GroupKFold is a splitter that keeps all records for a single user together. It puts every observation for a user, either entirely in train or entirely in validation. That prevents a model from learning user-specific quirks and then being tested on them. We will walk a tiny toy example that reveals leakage, then fix it with grouping, then compare, and finally run a grouped baseline so you see what honest scores look like. We will build this small diagnostic with 6 rows representing interactions and 3 users. Then move to grouped fold splits and a grouped baseline so you can reproduce this idea in your projects. Now we'll create a naive split that leaks user identity. This snippet exposes leakage by intentionally placing the same users in both train and test. We build a tiny feature matrix X with 6 rows and assign user IDs in the array G so each user appears twice. The arrays TR and TE simulate a naive split that separates indices, not users, so all 3 users appear in both sets. The variable leak computes the fraction of unique test users that also appear in train using a set intersection. Seeing a high leak ratio tells you your validation is inflated because the model can memorize user-specific patterns. Next, we will replace the naive split with a grouped fold. This snippet uses scikit-learn GroupKFold to prevent the same user appearing in both train and validation. GroupKFold receives X and the group labels G, and it yields indices that keep entire groups together. The variables TRG and TEG hold the first fold's train and test indices, and leak counts how many users overlap. Because GroupKFold assigns whole users to a single side, the overlap is 0. 0 overlapping users means your validation set reflects true generalization to unseen entities. In practice, you run GroupKFold with a chosen number of folds, and it cycles through different held-out user groups, so every user appears in exactly 1 test fold across the cross-validation run. Now let's quantify the improvement from grouping without training a model. This snippet compares how much user overlap you remove by switching to GroupKFold. The variable NA measures overlap in the naive split from earlier, while GB measures overlap in the grouped split. Subtracting them gives drop, the reduction in shared users between train and validation. This quick comparison quantifies the win from grouping without involving a model. A larger overlap drop means you've eliminated more leakage, making your metrics more trustworthy. Use this quick check on your dataset before you run expensive training. If overlap drop is small, grouping may not be urgent. If it is large, you must fix your validation. For a single randomized holdout that respects users, we will try GroupShuffle. This snippet uses scikit-learn GroupShuffleSplit for a quick, single holdout that still respects users. GroupShuffleSplit operates at the group level, so it selects entire users into the test split, just like GroupKFold, but does it in one randomized shot. The variables TRS and TES capture the split, and U lists the unique held-out users. The parameter test size controls how many groups move to test. Increasing it holds out more users and typically lowers optimistic metrics, while decreasing it does the opposite. The printed count confirms how many users you truly kept unseen. This is handy when you want a single stable holdout for final validation. Finally, we will establish a baseline under grouped cross-validation. This snippet runs a tiny grouped baseline with scikit-learn cross-validate and GroupKFold. We use DummyClassifier with the most frequent strategy to produce a stable reference score under grouped splits. The call cross-validate returns fold-wise test scores while respecting the group's argument, and the formatted print shows the mean across folds. This baseline reflects difficulty when users are unseen and helps you judge improvements from real models. A low CV mean here is expected and underscores why grouped validation is stricter but honest. Recap in 3 points. What it is. GroupKFold is a cross-validation splitter that keeps all records for each group together, so a single user never appears in both train and test. When to use it. Anytime your rows are correlated by user, session, device, or other entity, and you care about generalizing to unseen entities. One caveat. Group splits can increase variance in metrics because some folds may hold out hard or small groups. So use more folds or repeated splits if you need stable estimates. Next step. Swap DummyClassifier for a real model and compare performance under grouped and naive splits. Keep the same group's argument and observe how much the validation score drops when user leakage is removed. That drop is your honest measure of how much memorization was hiding in the naive split. If AI foundations in Python help, subscribe and watch the AI Foundations videos.